Okay, so thank you for the introduction. I go to share my screen. And so let me just uh, say 2 words about the, well, let's close this. Otherwise it continues to bother us. Okay, now this should disappear. Okay, so the session today is about many-to-many relationships in Power BI. Um, there are 2 main concepts that I will introduce now in the initial slide that I want to uh, include in this session. So my goal is to uh, make you aware of the different types of many-to-many relationships that we have, because sometimes this is confused with features that we have in Power BI, but in reality, in the data modeling world, sometimes the many-to-many relationship is something else that doesn't match exactly one-to-one with the feature we have in Power BI. Actually, these are 2 different things and they are both useful in different scenarios. So we're going to see how this works. Be interactive. So you can, I mean, I don't know if I'm able to see the chat all the time, but in case there is an important question, just stop me and let me know, because this makes the session more enjoyable, because otherwise I could start a recording and it's the same. I mean, I repeat the same things every time, so it wouldn't be different than from another session that I recorded other times. Okay, so that's the important, important initial note. So 2 words about myself. My name is Marco Russo. I work at SQL BI. We produce content for DAX and data modeling, which DAX is the language that used in Power BI, but is also the language used in analysis services, which is the product that is also included in Power BI, even though you see wrapped in a different package, but is actually the same engine. So this is what we do for a living. So we sell courses, we sell material, books, and so on, and you can find everything on our website. Now, let's go to the agenda. And by the way, you can download the sample files and the slides of this session using the QR code or the URL that you see in the screen. So these are the 2 topics I want to discuss today. One is what do we mean when we say many-to-many relationship between dimensions? This is a concept that exists besides Power BI. And then we will see what are relationships between 2 tables at different granularity. That is the place where I'm going to introduce the many-to-many cardinality relationship, which is a particular type of relationship in Power BI that doesn't cover the former concept that we will see in the first part of the demo. So the first part of the demo of the session is about what the world outside of Power BI think a many-to-many relationship is, which is actually what it is, and then what we have with a similar name in Power BI, which actually matches a different scenario, different requirements that we will see in a demo. So let's start with the first one. When we have a Power BI model, the best relationship you can create is a one-to-many relationship, which means that, for example, you have a table containing sales, and each transaction in the sales table defines an event happen at a particular point in time for a particular product, for a particular customer. So all these attributes that describe the transaction that we call a fact, an event, all these attributes are usually stored in different tables that are mapped using fields that says, okay, this is the customer ID, this is the product ID, and so on. So every row in the sales table has a number of columns, each one describing a set of attributes that usually is mapped to a business entity. You have sales, you have a transaction for one product, one customer in one store at a particular point in time. You have students and you have courses, and they take grades. You have the student, the course, the professor, the date, and the grade. So you see that whenever you think about that, you can identify different business entities that actually are important for the kind of analysis you do. And within each business entity, you have a wide range of attributes. What is the name of the student? What is the age of the student? Where he come from? And what is his path? Whatever group of attributes you have, they are always tied to the student. Same for the customer, same for the product, and they don't change for every transaction. But the price of the product could change over time. Good. So the price is part of the transaction, not the product name, because the product name is part of the identity of the product. So with this in mind, if you think about that, the more common relationship we have is the many-to-one relationship between the sales table and the product table and the customer table and so on. And Power BI is designed to make this kind of relationship the more efficient one. But then we have other kind of relationships in Power BI. And this type of relationship describes the cardinality at the two ends of the relationship. A relationship connects two tables. So the relationship is always defined by using the value for one column. And so you say the rows that have this value in this column on one table have a match on another table with the same value in a particular column. Now, usually you have for one row in customer, you have several transactions, one to many. Or from the sales table, you have many rows in the sales table that map to the same customer, many to one. There are cases where the relationship is one-to-one. You have two lists of students. One is the list of the students enrolled, and one is the list of the students enrolled for the I don't know, for the season, or for the school year. And another list is the list of the students that actually register for an exam. If you think about that, the student cannot be multiple times in the same exam or in the same season. So you can try to do a one-to-many, but actually you end up having a one-to-one. So you have basically different attributes of the same business entity in two different tables. Not recommended. It's like having a few attributes of the customer in one table and a few other from another table. But maybe that this happens in the real world because you have two different systems. One is the CRM, and the other is the accounting system, and a few attributes are only in one or the other. It's always better to create a single table in the transformation and avoid the one-to-one, but is an option we have in case of need. That is the option we have. And then we have another kind of relationship, which is the many-to-many. We will see this in the demo now. I want to go out of the light as soon as possible. But the many-to-many basically is a different relationship where you don't have to have a unique row for each value of a particular column. Now, when you have customer sales, you assume that you have one row for each customer ID. What happens if you have two rows for the same customer in the customer table? Which one is the right one? You don't know. So that's not going to work. But there are other cases where the many-to-many cardinality relationship can make sense. And we will see these examples later in the session. So the first scenario. So as long as you have one-to-many relationships, life is good, everything works well, no problems. But sometimes you have a different problem. You have two dimensions, two tables that describe business entities like the customer and the products, or matter, the customer and, as we will see in this demo, the bank accounts, where the nature of the relationship is a many-to-many. Let's see some examples. The more classic example is the bank accounts. You can go to a branch of a bank and you say, I want to open an account. You have one account, you have that account is owned by you, you own one account. That's it. However, you could open another account in the same bank. You have one account and then you have another account. Why? You know why, but that doesn't matter. So you can have multiple accounts. And these accounts have only one owner. One-to-many will work in that case. Customer, list of accounts, all good. Maybe that I have two accounts in two different cities, for example, just to make an example. But the bank also provides you the option of opening an account owned by 2 or more people at the same time. This happens for a company. This happens between husband and wife, or just between friends, or between in a family, brothers or sisters, or brother and sister, and it doesn't matter. What happens at that point? You have a certain amount of money in the bank account, and any of the owners of the account can withdraw the entire amount of the account. It doesn't matter. You are not saying 60% of this account is mine and 40% is of the other person, or 50-50. You're not saying that, because if that was the situation, you would have like part of shares of a company, which is another example. But in that example, you have a relationship that says, okay, I own a slice of the company. I own shares of the company. So you could say that in a report, the total of the profit of the company is split across the shareholders depending on the shares. So if you think for a moment, in that case, you have a many-to-many relationship, but actually it's just a way to split an amount. And when you think about that, when you look at the report, if the total of all the accounts is 100, the total of all the amount splitted between the customer is still 100. When you have a bank account, you are not saying, for example, 2 people have an account and there are $1,000. We are not saying you have one person has 500, the other person has 500. The 2 person can go to an ATM and withdraw 1,000. However, as soon as one person withdraw 1,000, the other person can withdraw 0. Otherwise, the bank has a problem. So how do we address this in the model? If you think about that, we cannot simply say, okay, this is the bank account. We split the bank account. So when we have 1,000, we actually have 500, 500. No, because if you want to provide the report, okay, what is the money I can withdraw? 1,000. What is the money of the other person? 1,000. As a family, how much can we withdraw? Still 1,000. You will never sum the same account twice just because it's owned by multiple owners. And this raises the question, okay, how do we model that? Now, in this case, we have this situation. For example, let's recap. We have 6 accounts and 4 customers. The first problem is, in order to define who owns which account, these 2 tables are not enough. We don't have the information. How can I know whether the account 1 is owned by Marco or Paul? It is not possible to just add a column to the account table, because that will work if the relationship was one-to-many. If each account has only 1 customer, we could add a column, customer ID, done. But it's a one-to-many. When we want to introduce in the model the notion of one customer can have multiple accounts, one account can have multiple customers, we need a third table. And this third table contains all the existing combinations between accounts and customers, all the valid combinations. For example, here we see that the accounts number 1, 2, 3, 4 are owned by a single customer. However, the account number 5, the account number 5 is owned by Marco and Paul, and the account number 6 is owned by Marco, and this is probably a mistake. This was supposed to be Marco and Luke or something like that. But the idea is that Marco, if I look at the slide now, Marco has 3 accounts. In this case, also Paul has 3 accounts, but I wanted to show you that Paul had 2 accounts, and for example, Robert or Luke has other 2 accounts. Important, this table must be received from the data source. You cannot invent this information. This is an information without which you are not able to establish the relationship between customers and accounts. So we say we have a many-to-many relationship between customer account, which are the 2 business entities. The business user wants to see these 2 business entities. But in order to define which relationship exists between each row of the 2 tables, we need a third table that could be invisible to the user that includes the existing combination. If we have this third table, from a physical point of view, the result we have is obtained by using regular one-to-many relationships. We have a one-to-many relationship between customer and accounts customers, and another one-to-many relationship between account and accounts customers. However, the presence of one-to-many, table in the middle, many-to-one, from a physical point of view, these two relationships plus one table in the middle creates a logical relationship that says customer has a many-to-many relationship with account. So from a high-level point of view, we're connecting customer to account. How? By using these relationships. And you could say, wait a minute, if I filter a customer, I don't filter the account because a customer filters accounts customers, that doesn't filter account. Wait, we are talking now about Power BI. Okay, let's see how this works in Power BI. If I implement exactly the same model we have seen before in Power BI, I end up having something like that. And I show you because of course, I prepared this model here. Let's take a look at the. Oh, by the way, I forgot to run Zoom it. Okay, so you see that we have 6 accounts. Now, in order to make it easy to understand what is the content of the table, we used these names, Mark-Robert, Mark-Paul. But actually, the name we have here is just something to make it visible and understandable. Imagine we had just a number here, which is, what we probably have. In terms of customers, we have only Mark, Paul, Robert, and Luke. So what do we need is this table that has this combination. And usually now we use strings to make it easy to understand, but usually you just have numbers here. You just have 1, 2, and 3, and then you have 1, 2, 3, 4. This is 5. This is 5, and this is 6. My mouse is not working well, and this is 6. But you see that basically what I have is just I could represent this just with the numbers, and usually we have number because the bank doesn't have names, has just numbers for the account number. Now, once we have this information, we obtain exactly the data model that you have seen before. What happens if we have transactions for the accounts? And we have a list of transactions. If we sum all the transactions of a bank account, we obtain the current balance, right? So we get all the transaction, all the deposit, all the withdrawals, and then we sum them together. We have the balance amount, the current balance amount. Well, let's focus on just transactions and accounts. Accounts has a one-to-many relationship with transactions. If we go back to this visualization and we just start with this, what do we see is that we have every account has a value which corresponds to the sum of the transactions of each account. So each transaction is considered only once. If you want to take a look at the transactions we have, this is the list of the transactions, right? And the sum we have of these transactions corresponds to 8,000. So this is the sum of all the accounts. Okay, good. What happens if I replace the account with the customer name? So I use the customer, but instead of using the customer here, let me show you the customer on rows. We always see 8,000. What does it mean? Let me show you. We are displaying this table customer, and we ask, okay, for each customer, show me the sum of the amount from this table. Now, if you look at the propagation of the filters, when we had a filter over accounts, the filter was propagated through this relationship. And so filtering one account was filtering all the transactions of that account. But when I filter a customer, what happens? If I filter one customer, I actually filter this intermediate table. This intermediate table is called a bridge table, a table that creates a connection, a bridge between two dimensions. And this bridge table doesn't have any measure, any data other than the existing combination accounts and customers. So I'm filtering those, but at this point, the filter doesn't propagate to accounts. It doesn't move forward because this is a simple one-to-many relationship with a single relationship. For this reason, if I look at this report, I see that Luke is not filtering any transaction. If I drill down these elements, you see that for each customer, I see all the accounts. And that's the reason why I always see 8,000. However, I can make a single change to this model here, and I can say, wait a minute, if I transform this relationship so that it propagates the filter from many to one, then I can see only the accounts of the customer selected and then only the sum of the transactions of the customer selected. So let's try to do this. Then I will explain that this could be not the best practice, but let's start with this change and see what happens. And now you see that because I enabled that propagation, when I filter Luke, I filter only the rows in the accounts customer table corresponding to Luke. And Luke has only one account. Pay attention, what will happen when I filter Mark? When I filter Mark, I will see Mark, Mark Robert, and Mark Paul. Let's see if this is true. If I go back to my report, you see that when I filter Mark, I have Mark, Mark Paul, Mark Robert. And the sum is 1,500, which is the sum of these three accounts. Now, take a look at what is happening here. If I go back and I show only the list of the customers, this is something that you might consider strange. The value we have here is 8,000. But the value we would obtain by summing these four customers seems much higher. It should be probably 9,000 and something, right? Because we are inflating 9 or 10,000. So 4, 6, 7, and 7, 8, and 9,000. So if you sum these four, the number should be 5,000. Why do we see only 8,000? Well, first of all, because the bank doesn't have more than 8,000. So the number is correct. How much money does the bank have in the accounts? 8,000. And why do we see these different numbers? Well, look at that. There are a few accounts, in particular, Mark Paul is here and is here. So this number has been computed as part of this number and as part of this number. But how many times do we want to compute Mark Paul in the grand total in the 8,000? Only once. The value in the grand total will always consider only the existing account once. It doesn't matter if you have this many too many. And this is a common mistake that you could make, for example, in SQL by joining the tables without realizing that you should do what we call a distinct sum of the value of the accounts, right? So we have to sum the accounts, but in the join, we don't have to compute the same account twice, which needs a much more complex query in SQL if you want to solve this problem in SQL with the same data model, because the model that we have seen is the right data model, is the right data model in any tool. It is not a specific feature for Power BI. We're just looking at, okay, what is the right way to model this business problem, the one that we have seen? And how do we obtain the right report in DAX, for example, by enabling the bidirectional filter, like I did now. Now I will show you a better way to obtain the same calculation without enabling the bidirectional filter, because the bidirectional filter, for other reasons that are not related to this model, could have other problems. In particular, for this model is good, but as soon as we add other tables to the model, the bidirectional filter will be activated also for any other calculation, even though we might not want to see that filter to be applied. We should see a much more complex example to do that, but I suggest that you look for ambiguity and how to avoid ambiguity in a data model. We have several articles and video also on the SQL BI website. So if I want to avoid exposing that, what can I do? Well, the best practice at that point is to change the measure. So I use this measure sum of amount, but instead of relying on the bidirectional filter defined in the model, I enable the bidirectional filter just in this calculation. How? There is a function called cross filter. You specify the two endpoints of the relationship, like accounts, customers, account, and accounts, account. And the last parameter specifies which kind of direction you want. The default is one way. We want bidirectional, which is both. So by doing that, you see that now I have exactly the same result for this measure. So I enabled the bidirectional filter only for this measure, even though the data model didn't change. But for the purposes of this session, the fact that we have a bidirectional filter in the model here or not doesn't matter. What matters is that if I have to create a data model representing a many-to-many relationship between two dimensions without any partition of the value, we have to use this technique. And this is important because if you had a percentage, if imagine you had a percentage here, right? You had a percentage of ownership. At that point, there is another way to do the same model, which is instead of having this complex model, you could just get rid of this table and connect the transaction to the customer and split the transaction into the two parts. If you have 50-50 and the transaction is 500, you create two lines, 250 to 150, because each one will assign to each customer its own share of the transaction. So when you have a percentage that you can assign, then it's completely different. You don't need this. Okay, you might say, but I don't have this data. Okay, but you can create the model and populate the model by applying the transformation when you refresh the model. But if you don't have this this percentage that is a static way to partition the value, the amount, then you have no options. You have to use this technique. And this is what we call a many-to-many relationship between two business entities, two dimensions, accounts and customers. No ownership in the middle. Now, let's go back to the slides. Questions so far?
No, there is no question in the chat, but if you have any question, guys, just raise your hand and you can ask it. You can unmute yourself and ask it.
Oh, I see that you posted the link to the video and the article. Very good.
Yeah, always.
Okay, so we have seen, just a recap, we have seen that the model is this one. The filter is not propagated automatically. If we use the regular one-to-many relationship, we have two options. We can enable the bidirectional filter in the model. We can enable the bidirectional filter in the measure. Usually we prefer the second technique because the bidirectional filter potentially could create some confusion, some problem for both performances and correctness of the numbers that you obtain, especially when you create a much more complex model, introducing more tables. Now, if someone of you heard about the many-to-many relationship in Power BI, which is a particular feature of Power BI, we didn't use it because we have seen a problem where that feature that I'm going to show you now doesn't help at all. Why? Because the many-to-many relationship is a logical relationship between two business entities that is implemented by the bridge table. And we need the bridge table and we need two relationships. There is no way to solve the same problem with a different technique. Without that bridge table, we cannot represent the relationship between accounts and customers. Full stop. But we have a different data modeling scenario where we might use a different type of relationship. This happens every time you have two tables that you could connect, but these two tables don't match by the granularity of the entity of the two tables. Let me describe with an example is simpler than this. The classic example we use to show this problem is the model where we have a budget. For example, the tables you see on the left date, sales, customer, product. These tables are the classic tables of a Contoso database, a company that sells products to customers online, on a website, all around the world. So every transaction, we know the customer, we know the shipment address, we know the product, we know the date, we know everything. And the granularity of the sales table is by product, customer, and date. We are, when we approach the end of the year, a company says, okay, let's create a budget for the next year. And usually the budget has a different granularity, a different analytical power. The budget says, well, we estimate to get this amount of revenues from this group of customers. For example, the customers in this country, and for this product brand will generate this amount of revenue. And we store this information in an Excel file or in a SQL Server table or wherever you want. The thing is that once you import this table in the model in Power BI, what you get is this table budget where we don't have a product ID. We don't have a customer ID. But what we have is an attribute of the customer, an attribute of the product. We have a budget where we have the budget for a group of products, for a group of customers. And now we have a problem because if we use the one-to-many relationship, we are not able to create a relationship between, for example, customer and budget. Why? Because a customer and budget could be connected by one-to-many relationship only by using a column that is unique in one of the two tables. So now, because the customer represents each customer through this unique customer key, where is my mouse? This is the customer key column that uniquely represents the customer. I have to use that column. I could use the customer code if it is unique, but I certainly cannot use country region because country region has the same value for all the customers in the same region. What can we do? How can we create a model where my ultimate goal is that I want to create a model, and I show you, where I want to do this. I want to show the sales and the budget in the same visualization, in the same table, compare them by brand. I have the budget by brand. Remember, the brand is something we have, right? We have the information of the brand in the table here. Let's see. In the table budget, we have the brand, no problems. However, if I don't do anything without relationships, I cannot create a single visual. What I could do, I could create another visual. Let me create another visual. And in this other visual, I remove the sales. I remove these two columns and I replace, so I create here budget with the budget brand. Now let's move, let's move this. I don't need this slicer. Let's move this here. Okay, so, I mean, I solved the problem, right? I have the budget. I have the budget by brand. I have the sales by brand. If I remove or I hide this column, it works. But what is the problem? If you do this way, if you do this, you have two visuals. And yes, because now they are aligned, but as soon as I start to, I don't know, I drill down here, this doesn't move. What if I want to create a chart? What if I want to create another measure that compares, that computes the difference between sales and budget? I cannot. So in order to enable the user to navigate into the data, we must allow the value of the budget to be browsable, to be filterable by using the existing columns that we want to show to the user. And now we have a problem. How do we manage that? Well, let's go back to the problem, the initial problem. Okay, so the initial problem is that we have this budget. Please note that at the moment, budget is just a column. I didn't create any measure. This is just the sum of the column. And as you see, it doesn't work. But without doing anything, I could do this. I could create a measure. Budget amount, where I say I want to calculate the sum of the budget where the budget brand is equal to the current value of the filter context. So for example, let me show you one technique. Current brand is equal to selected value of the product brand, because we are using the product brand in the report, and we want to use the current brand here. Just an example. I click enter, and I use the budget amount measure here. I just set this to 2 decimal points, a decimal number, and now I have my measure is working. So I use DAX to intercept the filter from one column in the in the model, the product brand, and I move this filter somewhere else. I don't like this, that the total doesn't work. So let me fix it. Instead of writing the code this way, I could simplify the code, and I can say, well, in reality, there could be multiple brands in values of product brand. And I can also save some line of code. And now all of a sudden, I also have the grand total. So now I like this because now, I mean, I have the number that I want, but I had to write code. And I mean, it just works. It's a solution, but it's not the more efficient one, because transferring the filter by using DAX is not the more efficient way to do the calculation. Moreover, I have to write more code. So the question is there a way to connect brand to brand before introducing a specific type of relationship? Let's see what can we do if we didn't have anything other than one-to-many relationships. Well, the reason why we cannot create the relationship is because we don't have a one side of the relationship. But if you think for a moment, we could say, wait a minute, if we had a table with one row for each brand, that would be a one-to-many relationship between brand stable and product and brand stable and budget. And then we will use that column to filter both. Let's try to do that. Now, if you think for a moment, we need a table, but the values for this table are already in the model. We don't have to import a new table from the data source. We already have the data. The data is the unique values in product brand, maybe also the unique values in product budget. So if I create a new table, brands, and brands is equal to, let's start with something simple. Let's think of product brand. What is brands? The list of the unique values in product brand. So far, so good. So now I use this table here. I connect brand and brand. And I would have to do the same for the country. Give me 1 sec. Now, if I go back to the report, and now I replace, if you remember, oh, this is funny. Hopefully this will not happen. This is, come on. Let me try to save this and open it again. This is a bug of the latest. This is funny. Let's try. Right. Now, usually when this happens, it happened with the latest build a couple of times. I don't know what is this one. Okay, so I open this again. Give me 1 sec. Hopefully this will fix the problem.
It always happened during the live session.
Yeah, I know. I'm not surprised. As you see, I don't panic. It's business as usual. So at this point, I was saying the brand column that I have now is the brand column from the product table. If you see the so I'm not able to zoom but you see that it is product brand. Now, if I remove this and I use the brands brand column, you see that now not only my budget amount is working. If you remember, this was the measure where I collected the filtered product brand, and it's still working because when I filter brands brand filters product, and so it filters the same product, and I transfer the filter there. But now this column in the middle, budget, is working too, and is providing the same number. Why? Well, because this is the implicit measure that sums the column budget in the current filter context. And if I'm filtering one brand in this table, what happens is that a filter in this table propagates the filter to budget, propagates the filter to product, and because we filter product, we also filter the table sales. So it just works. And this solution works. Oh, wait a minute. If I have a new brand in the budget for the next year, the table I created now doesn't include that budget, that brand. So what would happen? I will not see that particular budget. If you want to show all the brands that exist in either product or budget, then you have to use both tables. So we should use another distinct here that gets the data from a budget brand. But now we have two tables. We have to combine them together with a union. But now the union keeps the duplicated value. So if we have a brand in the budget table and the same brand name in the product table, and we expect this to happen a lot, we want to remove the duplicated values. So this is a pretty much a standard technique to combine all the values that we have in two columns we want to connect with this approach. So we want to create an intermediate table, but in this case, the table in the middle has values that already exist in the model, and we can create one-to-many relationship to complete the model. This works, and this is the only solution where we can see both brands that exist just in product or just in brands. Okay, this is important because I'm going to show you other techniques, but this is the only technique that you can use if you need to see all the brands no matter where they come. If you say, no, but we are confident that the product table has all the brands, okay, at that point, let me create the missing table here, because in reality, we also have the same problem for country region. But now that I know the technique, I need to create a table, countries, which is equal to distinct union of distinct of the country region from the customer table and the distinct of the country region from the budget table. So it's a pretty much automatic. You have the two columns and you can use this technique. Once I have the table, I just connect the table to the other two tables with regular one-to-many relationships. And now any measure just works by using either countries, country region, or brands, brand. So in an ideal world, we finished. And this is the right model for other products. For example, in multidimensional, that was the way we used to work. With Tabular and Power BI, we have one issue at this point, which is not a functional issue, is more a usability issue. If we show this report to the user, come on, the user will say, wait a minute, why do I have, let me move forward. Why do I have brand, brand, and brand? We have the same column in three different tables. User get confused because if you use the brand column from the budget table or the brand column from the product table, you will not get a correct result, because if you use a product brand, you don't filter budget. If you use brand from the budget table, you don't filter product, you don't filter sales. So you have to use the right one. You could say, well, no problems. You can hide this column and you can hide this column. But if we do that, we still have the user asking why we have a table for the brands, which is an attribute of the product, and we have category and color and product name here, why they are not in a different table. I mean, brand should be in product. The user expects to have all the attributes of a business entity. Brand is an attribute of the product business entity in the same folder. And in an ideal world, where I have Power BI working well, let me save this and close this again. In an ideal world, this is not an issue, because I, let's say, hide. Let me close also this one, maybe that this is disturbing. I could hide, sorry, not I could hide. I could group columns of different tables into the same logical folder. So my problem with the user interface, I would like to create a single container product with all the attributes of the product, regardless of the physical data model. So I would like to create a logical data model where I create my own vision, my own view of the model, even though the physical implementation can require multiple tables and other artifacts in the middle. But we are not in that ideal world. So we have to deal with the fact that for Power BI, the physical data model is what is shown in this data pane. And so if we want to use the product brand as the only visible user interface to the user, we have to hide everything else. No. So let's try to do this. So if I hide this and I hide this brand, now we are in an ideal situation. But guess what? If I remove the brand that I was using now, which is the brand from the brands table, and I use what the user expects to use, the product brand, we are back to square one. If I use product brand, only my measure that is not used in the new relationships is working. The existing implicit measure stopped working. However, now we are in a different position because now it is not true that we cannot transfer the filter. Let's do this. We cannot transfer the filter from product to budget. At the beginning, we didn't have any connection. Now we have a connection. However, this connection moves from product to brands and brands to budget. And if you look at the relationships we have, the filter does not propagate because the relationship between product and brands is a many-to-one relationship. Guess what? We already used this before. Well, we could enable the bidirectional filter. If we enable the bidirectional filter, now when I filter product, product filters brands, and brands filters budget. Similar to what we did before. So if I go back, and of course I do the same here. And what happens now? If I go to my report, my implicit measure now works. So now we have a model where the user can continue to see product brand, but when it filters product brand, it also filters the budget for those brands. Which makes, it seems that it makes my measure useless. I could use the implicit measure budget. Now, wait a minute. At this point, you say, wait. You said that this is bad, and now we should create a measure to do the cross filter. No, this is safe. This is one of the few cases where a bidirectional filter is perfectly safe. Why? Because from a physical point of view, I can see that I have a many-to-one and then a one-to-many relationship connecting product to budget. This is what I see from a physical point of view. From a logical point of view, what I see is product filters budget in a single direction. Think about this. When you apply a filter to product filters budget because it goes here and it goes here. When I filter budget, the filter does not propagate to brands. It stops. So from a high level point of view, I created a single direction filter between two business entities, product and budget, one dimension and one flat table. This is good. This does not create any ambiguity because the assumption is that this table in the middle, brands, will never, ever, ever, ever be connected to anything else. It will be only the table to physically implement this logical relationship. So the logical relationship is product to budget, but the physical relationship is product to brands, brands to budget. Now let's talk about the cardinality. If we define a table, so let's get rid of these lines and let me draw this again. So we are saying that we are connecting these two tables with a single direction filter. This is what we did, right? So this entire artifact that I created is actually creating this relationship. And what is the cardinality of this relationship? Many. Why? Because many rows in the product have the same brand, many rows in the budget have the same brand. What I've shown you in this area of the report is a physical artifact made by one table and two relationships that implements a logical relationship in the model between two tables with a many-to-many cardinality. And if you have this requirement, instead of creating a table like I did now, you can do what I'm going to show you now. Brand. But the suggestion that is provided here now, his is completely wrong, because we don't want a bidirectional filter between product and brand. We want a single direction where product filters budget, because this avoids the ambiguity. And if I do this, I obtain this. Oh, by the way, sorry. This can be active. The reason why it was inactive is because if we used the bidirectional filter, we would have had an ambiguity that is not compatible with making this transaction, this relationship active. But if we use a single direction filter, this relationship can be active, no problems. And we can do the same, of course, for the countries. Delete. Country region. Single direction, active. Customer filters budget. This model is a model that is perfectly safe, but this model is identical to the model that I built before. There are no functional differences between the model that you see now and the model I created before. Indeed, if I go back to the report, it just works as we have seen before, no differences. Which one is better? That's a hard question. Do not assume that this is faster. It is most of the times, but there are cases and reports. It depends on the number of values you have, the type of the report you build. We came to the conclusion that we cannot suggest a best practice. So I would say, if you know what you're doing and you want to create a many-to-many relationship this way, fine. Be mindful, it could have a performance issue, especially when the number of unique values you have in this column is large. Large means thousands, at least hundreds of. If you have 10, 20, 30 unique values, don't go ahead. I mean, you will never have a performance issue. But if you start having thousands of values, try both. Because there are cases where the other technique creates additional indexes, but these indexes could create additional scans. So it's a hard trade-off. There are cases where one is faster, cases where the other is faster, and it also depends on the report that you have. So don't make any assumption, oh, we have to use this because it is always faster. No. If you have a performance concern because the cardinality is large, try both and see what happens in your model. Now, this is what we did. And of course, at this point, there is an additional element that I will quickly show because I don't have, I don't want to go too long and I want to be open to the question. But let me show you one additional thing, which is the following. If I include the drill down by color, you see that now I am browsing the model. I'm navigating the model at a cardinality that is not compatible with the relationship I'm using. Every single time you include in your model this kind of relationship, many-to-many cardinality, 100% guaranteed, you have to face this problem. What happens if I create a navigation in the report that goes below the cardinality of the relationship? Because one brand can have products of different colors. So the color is not a group of brands. The same color can be present in different brands. And so because the color doesn't filter the brand, what happens is that we see here the value of the budget that is just the same value of Adventure Works repeated. You might think that you can live with that. You cannot, because if you show this particular report, there is a chance that the user understands what is going on. But as soon as we remove the brand from the report, now this is impossible to understand. Because what you see now in this and this, because now the two measures provide the same value, but this is the sum. of all the brands that have at least one product blue. This is the sum of all the brands that have at least one product black. If you look at this number is identical to the total. What does it mean? Every single brand has at least one product that is black. But for example, in this case, Azure, there are a small number of brands that have Azure, and so for this reason, we see that smaller number, and that explains what we see. But of course, this is confusing because if you show the user this report, how do you warn them? Look, this number doesn't make any sense. So the best thing to do is to hide the number if it is not compatible with the cardinality that you're showing. So what I'm trying to say is, it is true that this is easy to use. It is false that you should use it easily. When you use it, then you cannot use this implicit measure because this is confusing. So I would suggest that if you have that, stop implicit measures, take control, and in budget amount. So we remove from this report the budget implicit measure, and in budget amount, we want to write an if statement that shows the value only if should I show the value. So I had to write this condition. Now let's write true at the moment, and then comma. Of course, I want to replace true with the how can I detect whether I'm in the right cardinality. I could say, well, if you're filtered the color, then blank. So if I filter color, I do this, right? Why not? So this way, you see that when I have the value for the brand, I see the value. If I drill down, I don't see anything. If I remove the brand from the report, I see always blank, but I see the grand total. The grand total makes sense. Or I can go back and I show you the number again. Yes, but look at how many other columns I have. And okay, I can write many is filtered. Okay, wait a minute. And the day I will add a column to the model, I have to review all the measures. It is not easy to maintain. So, I mean, it works. It's not the best way to manage this. So let's say that we don't like this approach because it is too expensive to maintain. So we want to find a better way where we say, instead of writing if not is filtered, we want to write something simpler, something that works regardless of the column that we choose. What can we do? So at this point, I show you a technique that we can use basically all the times we have this problem, which is the following. Let's create two measures, and I create these two measures only to show how it works. Then these measures are not really useful. We can hide them, but just to show you how this works. Let's count the number of rows of the product table and show the number here. So you see that we have 174 products that are black in Contoso. We have 45 products that are blue in Contoso, and so on. Then we create another measure that computes the number of products at budget granularity. BG means budget granularity. I want to calculate the number of products, the measure that I computed before, but restoring the filter at the granularity of the budget. What does it mean? The granularity of the budget means that I want to remove the filters from the product table. All the filters in any column of product are gone, but I want to restore the filter only for product brand. By using values, even though I'm not filtering the brand, I'm filtering, for example, the product category. By filtering a category, I filter only the brand of that category. And so this list of the brands is the list of the brands visible in that particular cell. And for every cell, this is evaluated. Now let's compare these two numbers. You should notice that whenever the two numbers are identical, this number makes sense. Whenever the two numbers are different, we want to hide the value. So I can just compare the two numbers. If I go back to my budget amount, what I want to do is, if the number of products at budget granularity is equal to the number of products of the table visible in the filter context, I show the value, otherwise blank. And that's it. Now, with this technique, of course, I will get rid of these two numbers, but I want to show you that if I remove, for example, the brand, it just works because the two numbers are different. But if it happens that one color is used only in one brand, then I will see the value, because in that case the value makes sense. If that color is only used in one brand and that brand has only that color, it works. I mean, we can show the value. Why not? So that's the technique that we, of course, we should apply this technique also to the country region. But what I wanted to highlight is that whenever you use this kind of relationship, you no longer have a measure that is additive as it should be, because you could have a visualization of a set of filters that doesn't match what you actually want to see. And so you should at least hide the value. You don't like to hide the value, well, you could allocate the value. But this is a topic, and let me show you, because I don't want to. I think we have daxpatterns.com. There is a budget, there is a pattern we have where we explain here in the budget pattern. You will see basically the same problem with a more complex example in this case, and different variations. But the idea is that we introduce a way to compute how to allocate the budget. And so if you go at the color level, you get the budget for the brand, you split by the color with a business logic that you have to implement. Of course, this depends on the business. This is not something that you can invent, but you can find in this pattern a few techniques that we can use to replace the blank that I use now with a different value that could be, let's say, good to see for the user. It's an invented number, of course, but it could make sense more than just displaying a blank value. But this is not important, so I want to go back now to the slides to recap what we have seen. So we have seen that without a relationship, we had to transfer the filter. We have seen that we can transfer the filter by using DAX. I shown you a technique by using in values, which is the following slide. This is the technique that I used during the demo. Another technique that is slightly faster is using treat as, which is a little bit more efficient, but both treat as and in values are at least one order of magnitude slower than the technique based on relationships. However, in order to use the relationships, we have seen that we have option number one, create a table with the unique values that already exist in the model, so we don't have to import additional tables. It could be a calculated table with the existing values, and use this table to create a bridge table that allow us to propagate the filter from product to budget, for example. But in order to do that, we had to create bidirectional filters. This is the technique to get the values from both tables, if you want. And then the bidirectional filter is what we used to propagate the filter from customer and product to the budget table, so that the user can create a single visual comparing the budget and the sales in the same visualization, in the same chart, and so on. Then we made another additional step. The entire artifact, two relationships and one bridge table obtained with a calculated table, could be obtained by using a many-to-many relationship in the model. But it is important that we keep the single direction filter in this case, because the bidirectional filter we used in the previous case is only to connect one table, the customer or the product, to the intermediate table, not to the final destination. This way, the artifact creates a combination that only propagates the filter in one direction. Product filters budget, but budget doesn't filter product. The same result we want to obtain here, a single many-to-many cardinality relationship. You see that I use this definition, many-to-many cardinality relationship, and not many-to-many relationship, because the many-to-many relationship is what we have seen in the first part of this session. So this is what we did. We created a bridge table that had the unique values. So instead of having something that comes from outside, we had something that we obtained by the existing data. And now pay attention. In this case, the relationship between product and budget is a relationship that traverses many, one, many. If you remember, before, customer accounts was one many, many one. So one many, many one is the path we have in a many-to-many relationship between two dimensions. Many one, one many, or many-to-many cardinality is what we have when we use data that we have because we connect two tables at a different granularity, which is a different use case. And this table actually recaps the difference. You see one many, many one, many-to-many between dimension. This is the standard gold standard for dimensional modeling. Many one, one many is a different kind of approach that solves another problem. We cannot use, or we don't want to use, the snowflake schema, which was the brands table that is used in the report and filters both product and table, but we want to have a single table product with all the attributes, and we want to propagate the filter to the budget table. In that case, many one, one many. And this is internally, implicitly made by the relationship that you have in Power BI, even though the relationship in Power BI doesn't create this intermediate table. It's like it creates this on the fly at runtime. And so in certain cases it's slower, but in other cases it's faster. It depends. You have to do your test. But the important thing is that product filters budget, not the other way around. And we obtain this single direction by enabling the bidirectional filter only in one point between product and brands, not the other relationship, if we use the two relationships. So the conclusion is that we have these two different techniques. One many, many one, many one, one many. The first one solves one modeling problem and requires a table that comes from the data source. The second one solves a granularity problem that is specific of Power BI because Power BI doesn't manage well the snowflake schema, trying to create a view in the visualization to have all the attributes of the product in a single folder, even though they are scattered in different tables. And because we have to keep the physical model identical to the logical model we show to the user, we have to use these techniques to create a better user experience to navigate into the data. Questions?
Thank you so much, Marco.
Yeah.
Great presentation, same as always. So feel free to unmute yourself and ask your question, guys.
Yeah, of course.
I checked the chat. There was some questions, and I'm pretty sure you answered those questions during your presentation. But if anybody in the call has any question, please feel free to ask it now. Truly value your insight. I have often optimizing Power report question. Oh, that's a very long question, Moji. So there is, yeah, there is a question in a chat from Moji. This second one, I often struggle with optimizing Power BI report performance, especially when dealing with partitioning imported tables. I know the Vertipag analyzer can help, so could you please share your expertise on the best way to do this?
So the optimization is a complex topic because so there are two different things. So you might want to reduce the volume of data that you import. This can certainly help, but once you did your best to get the best compression and reduce the overhead for data that you don't need, then it becomes a question about how you optimize the DAX code that you write, the efficiency of the calculation, the algorithms, and so on. So I would split the problem in two parts. So the first thing is that you should optimize the model. Optimizing the model means reduce the volume of data and the granularity of the column that you import. Make sure that that you only have the information that you actually need. This is the first and simpler way to optimize a model. If you make sure, okay, the model is already optimizing memory, I just have slow performances, look at the DAX code. Unfortunately, it's not easy. We created a training which is called Optimizing DAX, which is now almost 30 hours of training just for the import mode. Then we are working these days for direct query and composite models that by the end of the year we will release, and this will add additional hours. So there are many things to consider. We also have now a service that is still in beta, which is daxoptimizer.com. You can enter the wait list if you want, which is I cannot show you because we are still in a private beta. But if you go to this website daxoptimizer.com, you basically obtain a sort of list of suggestions of what you should do in your model to improve the efficiency of the DAX code. So it's not about the data model, it's about the DAX code. You can still create slow reports, even though you use a DAX optimizer, because you might have a bad data model that you might have other. So it is not something that magically solves every problem, but it is a tool that can help. So it's probably you need both, but because this improves the productivity in finding the bottleneck. So especially when you have many measures and you don't know where to start, this could be very useful. If you have a small number of measures and you already made some training, so it's better to use DAX Studio and try to analyze what is the specific problem for a specific measure. But as I said, is a multi-day training is really takes you have to invest a lot of time other than the course of the training. And once that we will complete the video course, we will also publish the book probably. So the book now is available in preview for the current students of the video course, but once we will complete the entire course, we will also print the book for a general release.
Thank you. There is another question in the chat about are these the most common scenarios for a many-to-many relationship for the data model?
Okay. Clearly, in a session, we try to keep it simple because we want to spend the minimum amount of time to explain the model, the business problem. In the real world, it happens that these problems are applied to more complex scenarios where the principle is the same, but the model is made by 20, 30 tables, and the implication of the table that you connect with this technique could be more complex. But in general, the principle is the same. In my experience, I have seen the one technique is naturally used when you have to, because you actually have the data that are already structured that way. Okay, so it's unlikely that you have a wrong use of that kind of relationship. We could discuss about enabling the bidirectional filter in the model or not. I suggest to not do that because that could affect a measure that should not use that bidirectional filter, but that's a detail. The many-to-many cardinality is used in many cases where it is not the right thing to do. I have seen many cases where it was a shortcut to avoid cleaning up the data. But this is a bad idea because if this happens, you basically open the door to a number of problems. And one of the issues is the inconsistency of the numbers that you could obtain. I think I've shown you. I had to create a measure to check whether should I show the number or not. When I see the bidirectional filter created for the wrong reason, 100% the measure doesn't protect, which means that as long as the user produces the report that they designed initially, it works. As soon as another user creates another report, they have strange numbers. And when these numbers are not so much difference from now, I've shown you a problem where the difference was huge, but imagine that the difference is small because the color, imagine that 99% of the colors are specific of each brand. You will not have seen the problem if not comparing the two numbers. But one number alone is not immediately visible that you have a problem. So if subtle, sometimes it's subtle, sometimes you do. So for this reason, from my point of view, the more important part is that whenever you use a many-to-many cardinality relationship, you should protect the measure. Oh, but you have to write code. Yes, it's expensive. You have to think that that kind of tool is expensive. It has to be. It's not something that you should use easily. Of course, there could be simple cases where, for example, imagine that you have you have a customer, and you have the list of the sports of the customer. Now, usually is a one, many one, but you could have a many cardinality relationship. Let me think. You should create a basket of elements that you can use. Yeah. So the idea is that sometimes, let me show you. Sometimes what I have seen is this. So imagine that you have, instead of product, you have customers, and instead of budget, you have sports. So the table in the middle would be customer sport, right? So you have ID customer, golf. So for example, customer 1, golf, and 1, tennis. Then you have 1, soccer. Then you have, 2, soccer. Then you have 3, soccer, 3, tennis, and so on. So every customer can play many sports. Every sport can be played by many customers. The second column of this intermediate table could be just the sport. So if you show the sport, it just works. So instead of using the second table with just the list of the sport, the unique list of the sports, you could use the column that has the sport in the table that has customer and sport. Sorry, and in that case, I made a mistake. So in that case, you have this situation. So you have customer, sports customer. So instead of having this, you just have this one. At that point, you might say, okay, if I create a bidirectional filter here, it just works. True, it works. But when this table is large, is very large, it is more expensive than necessary. And sometimes it becomes a many-to-many, because instead of joining the customer, you join an attribute of the customer, which we should enter into a more complex thing. So for example, imagine that the customer has an attribute that describes a sort of classification, but for several of these classification, you have the customer belongs to a certain group, and the same group can have multiple so the same group can have multiple customer types, but the same customer type can belong to multiple groups. So you can use 2 tables, many cardinality, bidirectional filter, or maybe single direction filter from here to that, avoiding this other table. So that could be an option. And in that case, maybe that you don't want to protect the measure too much, because actually it's not, it's like you have is a way to model the fact that you have multiple values for an attribute, rather than you have the relation between 2 different dimensions. Okay, that's the difference. It's a subtle difference, but the idea is that, are you joining 2 business entities like customer and bank account, or are you just adding an attribute that can have multiple values, like the sports for a customer? A customer can play many sports, so I don't want to create a dimensional sport. I just create an attribute, which is a column in a table, but I try, instead of creating 2 tables, I create only 1 table. So these are the cases where using the many-to-many cardinality or just the bidirectional filter could make sense without creating the complete structure, but is never an error, is never a mistake if you do the full job. Because, for example, when you list the available sports, if one thing is accessing a table that has 100 sports, another thing is having a table with 2 million customers and other millions of rows just to list the 100 sports. Every time you open the slicer, you have a scan of a large table just to show a small list of sports. It doesn't make much sense. So from a performance point of view, it's never an issue to create the additional table. So it's up to you. But yes, so the model that you see in the real world are those patterns, of course, in the context of a much more complex model.
Perfect. There is another question from Daniel. Is this scenario also applicable to HR report where we have monthly granularity, like having a list of all employees for each month?
Oh, so the HR is an interesting word because you have a lot of problems that seem simple, but then create challenges. The biggest one is the performance. I try to summarize in 1 minute. So usually, when you think about the employees, you have a situation where you have an entity that has a start, a begin, and an end. So you have what we call, so just to give you a pointer to the, where can we find the example of that? So to see more about that, this is the events in progress. So this one. So the more generic patterns that you can apply to these problems is the event in progress. What does it mean? Every time you have a contract, an employee, an insurance, usually you have they start, they end, which means that within that period, that entity is active, that employee is hired, that contract is active, and so on. And when you have many of these entities, the problem that you usually have is you want to see at a certain point in time how many contracts were open, how many people were working, the headcount. Now we enter into a world where, as soon as you go deeper, what does it mean when you have 1 month? How do you consider those entities that started before the month, ended within the month, those that started and ended within the month? You have many possible intersections. And so you immediately have the problem of specifying, okay, what do you want to do? You don't have a single solution. This article actually tries to cover all the possible combinations, but you will see very soon that the first thing you have to do, what do you want to do? You have to ask yourself, what do we want to see? What does it mean by month? The end of the month, the beginning of the month, any day in the month. Each answer could have different solutions depending on also on the performances. Because in this case, the simplest technique that is just to scan the list of the employees and check whether the date is between min and max could be also the slower one if you have tens of thousands of employees or hundreds of thousands of customers or products or contracts. It's absolutely a no-go. And so there could be scenarios where you end up creating another table that produces the snapshot for every month, for example. You duplicate data, yes, but maybe is the right thing to do if you want to get good performance. So it's usually a trade-off. So if we want to have a quick performance and we want to generate reports that compare different people, because doing this problem, solving this problem for one period is easy, performance-wise. But when you create a line chart and you see the trend for 36 months, that's a completely problem because you multiply by 36 the cost for what you do for 1 month. And all of a sudden you will see that the number of rows that make your report fast enough start to be much, much smaller. So this article, I think, will help you trying to figure out all the possible solution. I know that for the HR, there are a few specific things that we could add on top of that, and that's maybe something that is good for a future pattern, but this is what we have today.
Perfect. Thank you. There is another question in the chat
I just
box.
have 2 minutes because then I had to go.
Okay, yeah, a little bit fast. That's about the snowflake model with the 1 fact and 2 dimension, and the fact is connected to dimension 1 many-to-many bidirectional, and dimension 1 is connected to dimension 2 many-to-1. Are there ways to summarize the fact by dimension 2?
It's very dangerous because so first of all, if you have a many-to-many bidirectional a many-to-many bidirectional filter between a fact and a dimension is something that I can hardly justify. So it's to me, there is a problem at the beginning, which is why the model is made this way, why it is not solve the problem in a different way that will make it easier to create additional things. Nothing stops you by from creating something by DIM2 and aggregate, but of course you're going to create a huge issue in consistency of the data, because probably the many-to-many introduces a number of problems, and also in the calculation, like we have seen before. So you first of all, you have a many-to-many cardinality relationship. Did you protect your calculation for any filter over DIM1? This is the first problem. If you solve that, then of course, as long as DIM2 doesn't go at the granularity level that could be ambiguous for the calculation, it can work. But I cannot provide a generic answer, of course, because it depends.
Yeah. Okay, thank you so much. Thank you for sharing your knowledge and time with us, Marco. Hopefully in the future we can have more session with you. And thank you everyone for joining us. Have a good one. Cheers.
Thank you. Bye-bye. Bye-bye. Thank you.